Okay, just like the previous module where we talked about minerals and igneous rocks, I'm going to try and run through some more images of sedimentary rocks and metamorphic rocks just to get you up to speed. Same thing, because we're not looking at real live hand samples and you get to look at pictures only, it can be a little challenging, so I want to show you as many pictures as I can to kind of get your eye tuned into what we're looking for. So when we talk about sedimentary rocks, remember, this is the chart that we're going to use for that. And it has a lot of extra stuff on here that we're not really that concerned with because we are doing, remember, kind of the basics. But the deal with sedimentary rocks is that there's two categories. The first one are these four rocks right here: breccia, conglomerate, sandstone, and mudstone. These are what are called clastic, or sometimes you'll hear the word you see over here, detrital. Just means pieces, so fragments of pre-existing rocks that have been weathered and then transported somewhere, dumped somewhere. And so remember from the lecture, then we take those pieces, we bury them, we compact them, and as water moves through the little open spaces between the pieces, we can cement them together, and voila, we get a clastic sedimentary rock. So the story with these is we evaluate the size and shape of the pieces to help us name what we have for a sedimentary rock. The other category has a couple names, but we're calling it mostly chemical, though there's some biochemical stuff there. And the same thing, we're not interested in every single rock here, but there are a few that we're concerned about. And so we want to look for limestone, chert, rock gypsum, and rock salt. Because these aren't made of pieces, typically, we can't use the same process. So what we're looking for is, what are these composed of? And so if we can figure out what they're made of, then we can name it. So you can see over here there's a composition column. And so we have to harken back to our minerals that we looked at in the previous module and figure out if we can determine if one of these rocks is made of calcite, we know we have a limestone. And of course the test for calcite is it reacts with acid, so we can do that and then we know we have a limestone. Or a chert is made of silica. Remember, silica, SiO2, is just quartz. We know a property of quartz mineral is that it's super hard. You cannot scratch it with a steel nail. So if we identify that, we know we have the chert. Gypsum, mark it with your fingernail. That's pretty soft. That's a diagnostic feature. And of course, the salt tastes salty. And so the first part is to identify whether you have a clastic or a chemical. Sometimes it can be challenging, but for this class, trying to present you with samples that are pretty easy to figure out. And this one is certainly an easy one. It's got lots of pieces there. So they go from big to small, and we use terms like gravel, sand, and mud to describe sizes of pieces. And so for us, we're going to say that anything bigger than 2 millimeters is considered a gravel size piece. Anything between 2 millimeters and 1/16 of a millimeter is sand size pieces, and smaller than that is mud size pieces. Think of beach sand as your kind of way to hone in on the size of sand size pieces, okay? And so if we can put those category, gravel, those are the bigger rocks, we're going to look at conglomerates and breccias. Sand size pieces, hey, sandstone. Mud size pieces, luckily, mudstone, okay? And so if we look at some samples of mudstones, here's a couple more pictures. So they're typically fairly layered, thinly layered usually. And they tend to be in this darker color, so a blackish or a reddish is the typical, but they break into thin sheets. And so they do have some layering, but it's usually very thin. And then let's see what else I got for you. And so just like others, I mean, sandstones, there's a bunch of varieties based on what they're made of. We're not really concerned with that here. We're just looking at the size. If they look like beach sand grains, and we're going to call them sand-sized pieces, and this would make this a sandstone. So we're looking for us more like something like this or this, whereas the kind of the typical quartz sand. But you can have obviously sand that's made of something else. But for us, we're going to look just kind of at the basic quartz sandstone. And then let's see, as we look at more and more pieces, we want to look at, what do we got here? A conglomerate. So now we're increasing in size, right? So now we have the conglomerate that is, I'm going to do, don't look at that at all for a minute because I don't want to confuse us. So greater than 2 millimeters for us is the story we're telling here. And so what's the difference between something like this and something like this, that we're also ignoring that, is that you can see the shape of the pieces is what distinguishes between these two that have larger class sizes. Okay, so we have these big class, bigger than 2 millimeters. This one has rounded pieces, and the breccia has angular pieces. And once again, the composition of the pieces can vary. We don't care, right? We want to just look at the size and shape and say, oh, these are gravel-sized pieces, and if they're rounded, my chart tells me it's a conglomerate. If they're big and angular, my chart tells me it's a breccia. And remember, we're not looking at the shape of the rock itself, but the pieces within, okay? And look, if you can do that, then you can master, in theory, the classic sedimentary rocks. Size and shape, and you're golden, and you can figure out what the classic sedimentary rocks are. The second is the chemical that we talk about. And so let's see if I can find us some cool images of some chemical rocks. So we talked about you have to know the chemical composition. So you're performing a test on these chemical rocks. And for the rock that's called chert, it says it's made of silica or quartz. So the test is to try to scratch it with a steel nail. You're not going to see layering here. Sometimes it's fairly shiny and smooth as an indicator of chert, but certainly the test is something that we're going to do that helps us figure out what we have. Evaporites. So for this class, we care a little about halite and gypsum because these are samples or rocks that can dissolve when exposed to water, and you can get large deposits, salt deposits, that are in big layers like this. So these are the minerals that make up the rocks. Usually we call halite rock salt and gypsum rock gypsum when it's in these big huge layers like this. But they can be a hazard because they can dissolve over time. So if you have buildings that are built on layers of salt or gypsum, they can dissolve over time. And then the other one we want to look at is, let me jump around to our limestone. So look, there's a ton of different limestones that we could look at, but this is kind of the typical limestone we care about. It is, some of these they look like they're fragments. Really, they're fragments of shells, because a big source of the calcite that makes up my limestone is from the dead shells of animals and pieces of coral reefs that have broken down into small pieces, been buried and kind of put together. Sometimes the pieces are big, but for us, we're doing this more crystalline looking one. It's just super finely crystalline. But just like our other thing, we need a test. All of these would react to acid. We put a little drop of acid, it would fizz, you'd be good to go, right? And so that's what you would look for these. So test. That's what you want to do when you look for trying to figure out the chemical. And so you're going to just play that game of size and shape for here, and for the ones that I'm asking you about, limestone chert, the rock gypsum, the rock salt, you just got to know how to identify some of these minerals, and then you can use that to figure out what type of rock you have. All right, so hopefully that won't be too bad when it comes to sedimentary rocks. The next category I just want to do a quick review on is our metamorphic. So same thing. This is your friend. I mean, in the lab, there's descriptions of the rocks themselves. There's, you know, some reading you can do that kind of help you figure stuff out. But the charts are certainly good because they condense a lot of information. So look, same thing. We don't need to know all of these rocks. But like all rocks, we have categories. So we have two categories here. We have what are called foliated rocks, just these four here, 1, 2, 3, 4. And then we have non-foliated. So if you remember from lecture, the deal with that is that the foliated rocks are kind of a texture where the minerals have lined up and it looks like some type of layering has developed there. But it's from what's called differential pressure, and usually this is associated with some convergent plate boundary. We've slammed these plates together. Pressure is enormous in this horizontal direction, and with enough heat and fluids and all this kind of stuff, we can slowly alter these rocks into something else. And one of the ways they get altered is these minerals kind of line up like that and form a foliated texture. So we argue that foliated texture means high differential stress or pressure, and so we want to associate that texture with that type of environment. We can also look at this. You can see over here there's this little column here that indicates that as you move down here that the grade of metamorphism increases. So we would argue that slate is a low grade metamorphic rock, which means it hasn't undergone as much pressure as the others or heat, and so as we move down, gneiss is the most extreme metamorphic grade of the four here, and so it just goes from here, the next, the next, the next. Those are the foliated ones. Regional metamorphism is the term. And then there's the non-foliated ones. And for us, yes, there's a variety of ways we can get non-foliated texture, but the argument here is that instead of having high differential pressure as the driver, we're having high heat as the driver. And usually that's associated with magma moving inside the earth and baking rocks it comes into contact with. And so the two we care about are quartzite and marble. And same thing, kind of like with the sedimentary rocks, the way to ID these non-foliated is to figure out what it's made of. So, got to go back to our mineral knowledge. A quartzite is made of mostly quartz. So the term here for a protolith, remember that's what it used to be before it was altered. Aragonite is another word for sandstone. So think of quartz sandstone. This is made of quartz. So my test is I can't scratch it with a steel nail. And marble used to be limestone, but was baked. And so limestone is made of calcite. Calcite reacts to acid. Limestone reacts to acid. And so, of course, so does marble. Okay? And so those really are the only 6 that you need to worry about. Talked a little about this, remember, the regional and contact. There are others, but we only care about these 2 for now. So high differential pressure is the driver here. High heat is the driver for contact. Let me jump to a few pictures. Let me show you this real fast. This is this idea that within the rock there are minerals that are elongated like this, and if you crush it in one direction, they'll start to line up. And this is that texture that we talk about, foliation. And so sometimes it's really hard to see. This is a slate. What? It looks almost like this mudstone, which is the protolith for that. So it tends to get a little shinier, but not much. Tends to be a little darker. Dark gray is a typical color for slate. But we can take these rocks and increase their metamorphism. So the next one up is what's called a phyllite, and it's a little more shiny, and the layering is a little more easy to see, I guess. So even though I said layering, it's really foliation, remember. So we can go from here. Here's the parent rock, mudstone. There's a slate. There's a phyllite. And then we can keep going and say, oh, the next one is a schist. Now, schist, same thing, comes in a variety of shapes and colors, but typically it looks like this one. It's kind of scaly, shiny. The crystals are pretty big. You can kind of see them reflecting the light like that. So that's my schist, and here it is here, right, in order. This is what I start with, my mudstone, slate, phyllite, schist. And then finally the higher grade metamorphic rock that's foliated is our gneiss. It's just kind of layered light and dark. And same thing, we can start from a mudstone and create all these. If it stops here and the pressure is released and it gets uplifted to the surface, we have a slate. But if it keeps going and going over time, we can develop into a gneiss. And of course that process can stop anywhere along the way, and then we would get those rocks there. And then finally we talk about the marble and the quartzite, remember? And so they can look very similar. They almost look like melted sugar is a description that some people use for that. The key here is you got to know what it's made of. So we use the test. This is a very typical quartzite for Arizona. It's this reddish quartzite here that's up in northern part of the state. But we know quartz, we can't scratch it with a nail. We could try that test. Or with the marble, we would do a fizz test. right? So we would put some hydrochloric acid on here. It would react to that. That would tell me it's made of calcite. I know marble is made of calcite because it used to be limestone, which is also made of calcite. So remember, non-foliated, high heat is the driver here. We're looking for a reaction from hydrochloric acid to help us with that. The quartzite, we have to try to scratch it with a nail. No scratch means it's quartz, means it's probably a quartzite. Okay, so same kind of deal. You want to remember, obviously, how to identify these and then what they mean, right? Regional versus, what's the other one? Holy crap, contact metamorphism, right? All right, so hopefully looking at some of these images will help you with kind of figuring out when you go through the lab. But try to be consistent with the pictures in the lab, so I don't think you'll have any trouble. But as always, if you do, make sure you reach out and ask for lots of questions and ask me for help, and I'll be happy to do that.